Hello and welcome to this talk about building a graphical IDE in Elm and Purescript. I am Claudia Doppioslash. I'm a functional programmer and a game developer, and I write on Lambda Cat about functional programming. I work for Pestritzinger GmbH, where we build embedded Erlang solutions for industrial control in the automotive industry, like this sort of stuff, like this smart conveyor belt, which is actually running Erlang. It's running the beam. And we also make an Internet of Things embedded board, which is about to come out. And you can run any language that runs on the beam on it, including Elixir. So I got Wi-Fi and a lot of stuff, and it's bare metal, so maybe check it out. So I'm going to say, why are you here? My first guess would be you need to get some front-end code done, and you detest JavaScript. Who here is like that? Everyone. You might also be interested in Haskell-like languages or undecided between choosing Elm or Purescript for your own project. So what you're getting here is not an Elm or Purescript guide, and also it's not the latest Elm version, but it's our work in progress model. We're still working on this, but I'm going to talk to you about the choices we made, what went right or wrong, and just enough of Elm to know what's going on. And also our experience porting a project from Elm to Purescript. So about Elm, I'm going to talk about version 0.16 because we're still on 0.16. And from 0.16 to 0.17, they removed a bunch of stuff. They removed functional active programming, mailboxes, addresses, signals, and fold P. So if you see any of that and you're doing Elm now, you don't need to know about that. It's gone. So don't worry about it. So our project is a visual IDE for a PLC language, which has got the nice, cute name, EIC, numbers, blah, very memorable. And PLC stands for Programmable Logic Controller. And it's sort of a parallel universe, parallel development of software development. So it's based on function blocks. So if you see it on the left, there is a function block. On the top, there are events. On the bottom, there are variables. And on the right, you can see that there is some screenshots on some other IDEs. But we didn't want to do just another IDE. We wanted to do something more interesting. And we were inspired by the Brett Victor's talk, Inventing on Principle, which I totally recommend to everyone. And we ended up with this. So you see on the right, there are the function blocks. And imagine they're connected in graphs. Haven't done that yet. And on the left, there are the history of variables as they changed in the last 60 seconds or so. So you can see, literally see what your variables are doing. And our deployment is a bit unusual. So there is a PLC language, which we have a compiler for, which compiles it to beam files. These beam files run on the beam on bare metal, on those embedded boards that you saw, and also Cowboy runs on them. So it can send us the information from the PLC programs to our IDE, so we can figure things out. For this project, there were a few requirements. Mainly, it needed to be very cross-platform. They needed to support any PC, iOS, and also the iPad Pro. The performance didn't need to be amazing. It just needed to be interactive. So 30 frames per second would be fine. So what we ended up doing is choosing web technologies, because why rewrite the same thing 3 times or 4 times? Let's just use web technologies. And that means JavaScript, CSS, and SVG, but JavaScript. Let's not do that. Just no. So we had a bunch of choices. We are a functional programming shop, so we wanted to stick with functional programming if possible. So there was ClojureScript, CoffeeScript, Elm, and TypeScript. And I think you know what we went with. So Elm. Why did we choose Elm? Elm used to have functional reactive programming, and that was actually for us the main reason why we wanted to use it, because we felt that was somewhat similar to Erlang, and we were also interested in it, so that's why we chose it, but that is gone now. But still, Elm is still good. Also, the great error messages. In fact, they're so good, everyone is imitating them, even Haskell now, and Rust is doing that as well. And also, some concepts used to be somewhat similar to Erlang, like mailboxes, was similar to Erlang, but that is gone as well. So what is Elm? It's a purely functional, strongly typed, eagerly evaluated language that compiles to JavaScript. It used to have functional reactive programming, And it's got an Haskell-like syntax, but without the strange squiggles. And it's also a very small language, and it keeps very small because they tend to remove stuff that's not used so much. And now it's also optimized for learning curve. So if you have functional programming experience, you're probably going to be able to learn it in a few weeks. It's similar to Haskell, but it doesn't have type classes and advanced types. So compared to JavaScript, which was the other candidate, the main advantage is if Elm compiles, it will work at least 90% of the time. I confirmed that is true, almost no runtime exceptions. That was a big win. Also, you can be very confident when refactoring because what you can do is basically change your code any way you see fit and then mindlessly go through any compiler errors until they're over and everything works. And this works. It's also a very clean language, much more powerful than JavaScript. You don't need as many lines of code. And you know the famous error messages, which are certainly better than undefined is not a function. About them, I think the main thing that makes them great is that they are contextual. They don't tell you, oh, there is a problem with your code on the line 356 of this strange file you don't even remember writing. But they show you what is going on. They show you the bit of code that's got a problem, and they also try to suggest you ways to fix it, if it's possible, and that is very good. And to achieve this goodness in error messages because they made it a priority. They encourage people to send bad error messages to a Git repo, and then they went through them one by one, and they fixed them. And also, it's because Elm made a very conscious choice about type system complexity. So it's more powerful than Java, way more powerful than Java, but it's less, the type system is less powerful than, say, Haskell. And that helps when making good error messages because there are less moving bits around. So that is something that made good error messages possible as well. And also compared to JavaScript, you know, Elm actually makes sense. I don't know if you've seen the VAT talk, but at some point in JavaScript, if you wrote array 16, you will get 16 commas. That doesn't make sense. There also are some cons compared to JavaScript. The JavaScript interoperability is a bit inflexible. It's gotten more flexible after 0.17, but it's still a bit, maybe it's a lot of work to wrap a big JavaScript library. Also, it's a new language. It was still 0.x, it still is, so changes may happen. But all in all, we thought it was fine. So our project structure is a bit unusual. So we have this PLC board, an embedded board, that runs this bare metal beam on. And the PLC program runs on the beam, and Cowboy and the bullet library also run on the beam. So we have a server and a WebSocket library. And these two talk to each other, and they send, through WebSockets, information to the browser, which is running the bullet client library, which communicates through Elm ports with our WebSocket library, which send information to the PLC IDE. And then I'll show you a demo. So this has been running since yesterday night, still running. And you see the function block, you see the events firing. Is everyone seeing this? No? Let's try bigger. Better? Yeah. Still some no's. You might not see much of it at this rate. OK, well, let's try this. So this is a PLC application, which is a semaphore. So you can see here red, yellow, and green. Yeah, they're not the same colors as the IDE. I'm sorry about that. So this is green and red. If you look at green and red, green and red, red and green. So if you look at them, you can see that they never overlap. And if you look at the yellow down below, should probably add the functionality to make it so it matches the name of the variables, but use some imagination, and you can see that the yellow never overlaps with a little bit of both. Just make it a little bit smaller so you can actually see all of them. So you can see how seeing your variables, as they change in time, is useful for debugging. So if they're overlapping in places they shouldn't, you're going to see it. And that was it. That was the demo. So going on with the PLC IDE structure, as I said, we have the PLC device, and we have a bunch of components. We have the Elm library, which is the WebSocket library, which is a component. I know in Elm, a component is a bad word. Bear with me. It wasn't a bad word yet at the time. And we have a decoder component, which decodes the JSON that comes in from the WebSocket library. And we have a rendering component, which renders it to the browser. And then the UI interaction is captured, and it's encoded in messages that go back to the PLC device. So that's how clicking on stuff gets me the plots on the way back. So these are 4 components. And these are components because in 0.16, the Elm architecture was called startup. So those are actually startups, 4 of them. And it wasn't as in 0.17 where the Elm architecture is the language. You could still do many things with it that are not possible. I mean, they are a bit awkward to do now, at least. So the way it used to work, you would have an address which brought you to a mailbox that you will send actions to. And when you send an action, it will get to the update function, also with the current state of the model, and then that would be calculate the new state of the model, and then render it to the view function. And then in browser input would send another action through this, and it would go in a loop forever. And that was 0.16 startup. And this app is made of 4 startups that are connected by mailboxes, and they are wired again in a parent startup, which means we got nested startups. And this structure is a bit unusual, and I don't think it's really done anymore. And it was invented by a GitHub user, Foxdonut. We adopted it because we wanted to keep things separate. We didn't actually want one source of truth, because that was, this way it's more Erlang-like. And also it was easy to expand. We could add new components whenever we wanted. So it was quite good for us. But it was never ported to 0.17. It might be impossible. It might be possible. I'm not sure it's worth the trouble. And so this is why we're still on 0.16. This works. As you saw, it still works. Still 0.16, solid. And we used FRP heavily. And yeah, it's a bit awkward to change it. And also, this project has a budget. So porting code would cost money that we don't really want to get the client to pay for. And also, we were a bit frustrated with the lack of communication because there weren't any deprecation warnings. There was a brief beta version, and that was it. And it was too late for us to change direction. So we're waiting for Elm Evolution to stabilize, coming back maybe in 1.0 and see how it is. And in the way of making this, we solved some production problem about working with Elm and JavaScript, and working with Elm with Erlang. So one of them is how to organize subcomponents if your app is getting fairly big. And also how to include an Elm project into an Erlang app. So maybe what we wanted to do is to have various Erlang apps, each with their own front-end code, and just to be able to use that nicely. And then how to store dependencies that cannot be sent to elm-package, because you can't send JavaScript code to elm-package. And one of our libraries had got JavaScript code, so we had to deal with that. So organizing subcomponents ended up being pretty simple. So we just have one directory for each component, and then we just break the files up in action, model, view, and update. And feature is the wiring needed for the structure that I showed you. And then everything is wired yet again in another Elm file, which I called app.elm, and then we feed that to the main.elm. Mixing Elm and Erlang projects also turned out to be quite simple. We just have an Elm subdirectory in the Erlang project, and then we compile the Elm files to priv, and then we just add the JS to your HTML file, and that was it. And we made a rebar tree plugin for this, so it's pretty convenient. About non-package deps, that is a bit more awkward, because you have to keep it in your own repository, and so we fetched it from our own repository, and then we store it in a subdirectory of the Erlang project, not with the Elm files. And then we move only the Elm files to a subdirectory of the Elm project, not under Elm stuff, because then you would risk messing up Elm stuff, messing up the Elm package manager. And then you include the subdir in elm-package.json, and that's it. So about rendering, we had a bunch of choices. We could have made our own WebGL 2D rendering engine, which would have been really cool, but we didn't. And it turned out SVG was a decent option, so we used it. We could also have used HTML, but that would have been fairly awkward. So we ended up using SVG with as much CSS as we can possibly use, because animation in Elm needs to keep a lot of state around, and it's a bit awkward, while this is the role of CSS, so we just use it. And for this, having an expert on call, an expert on SVG and CSS really helps, because I really don't want to debug CSS if I can help it. And one really good thing about Elm, I think, is the great syntax for the Elm, the HTML and SVG generating libraries. Even if you've never seen Elm, that makes sense. You see the tags, you see the attributes, you see the nested tags. So I think it's really well done. And also it's based on virtual DOM, and they are quite dedicated to make it as fast as possible. So concluding a bit about Elm with a few caution measures. So you should be aware, if you want to use Elm with your project, what Elm is good for, which basically means if your app is a good fit for the Elm architecture, then everything will go swimmingly and great, and will be fine because all the choices are made for you and they are good choices. But if it doesn't, then you have to fight it, so there might be a bit of a problem. Also, if you need to wrap big JavaScript libraries, it's a bit awkward with the interop philosophy of Elm. So if you need to use D3, maybe Elm is not a good fit. Also, Elm is still experimental, so you might have big changes or you might not, but you should expect to rewrite some of your code with each new version. And really, the problem with that is that Elm doesn't really have a roadmap. It's a bit more inspiration-based and exploration-based, so they don't want to commit to having a roadmap. There are beta previews, and there is the Elm Dev mailing list, which you should follow if you want to keep up with Elm's changes, especially that file over there. It's the philosophy they have on roadmaps. So what next? We skipped 0.17, 0.18, we probably skipped 0.19. We probably come back when Elm is nearer to 1.0. And so meanwhile, we're taking another language for a spin. And now there are a bunch more options. There is Reason, there is Purescript, there is Fable, and there is Purescript. They're breeding like rabbits. More and more. So yet again, we have to choose wisely or be condemned to just recode everything in another language. So our first choice was, Elm, please adopt me. I won't mention Monad. Everything will be great. Which was nice. But it made a lot of choices for us. So as a reaction for that, we chose Purescript as our second language, which is a language which gives you a lot of power, and then you deal with it. If you can cope with the types, you can do everything. So what is Purescript? Purescript is a purely functional, strongly typed, eagerly evaluated language that compiles to JavaScript. Where have you heard that before? But it's got advanced types, like type classes. You can have functors, monads, applicatives, everything you like. Also, it's got Haskell-like syntax with all the squiggles, possibly more squiggles. And it generates readable JavaScript because it doesn't have a runtime. So if you can actually read the code it generates, and it makes sense without you having to keep in mind how the runtime works. There is no runtime. Also, the community is very nice. It's quite small, but it's very open. They got an IRC channel, a Slack channel, a Gitter channel, a video online meetup. They got everything. It's very, very communicative. And so going on to philosophy differences, makes all your choices for you. It wants to be simple above everything else. It wants the learning curve to be really quick, and they really managed to do that, especially now. Getting rid of FRP did give them that, because when people got to mailboxes and addresses, it was like, what is this? And now it's a bit more of a plain learning curve. But in Purescript, on the other hand, it tells you, well, you can have everything. You can have all the features you want, but it will take some time to learn them. In fact, it could take quite a long time to learn them, but you don't have to learn all of them to start with. You just only need a bunch. And Elm gives you only one program structure. All your choices are made for you. And in Purescript, you can do whatever you want, pretty much. You can invent new structures, everything. So why do we choose to have Purescript after Elm? Elm makes a bunch of trade-offs, which they do pay off, but they also have consequences. So having simpler types make the learning curve much smoother and makes the error messages really great. But it also produces more boilerplate, and you have to repeat a bunch of stuff because you can't abstract it away. Also, the components don't really compose, but it is a choice, but still, it's a choice. So why would you use Purescript after Elm? For me, it was about the types. I actually come from like Clojure and dynamic programming, but I got used to the types in Elm, and I actually liked them. So I thought I might be ready now for some more advanced types, for more power and less simplicity. So if you get restless with Elm's boilerplate, you're in actually a very good position to figure out these higher abstractions because you're going to use them. You're going to abstract away the things you've been repeating. And some of the approaches to that are also generating the code, but I think the abstraction-based path to get rid of boilerplate is more fascinating, for me at least. Also, it's similar enough that I don't have to rewrite everything. Had I chosen ClojureScript, I would have had to rewrite everything. But in Elm, you can sort of port an application from Elm to Purescript, and it still will make the same sort of sense. And it's more similar in syntax-wise as well. Also, it benefits from following Haskell from a distance. They look at the cool stuff in Haskell, but they don't just adopt it straight away. They wait for a bit until people have figured out a decent user experience, and then they implement it. Also, the community is very nice. It's small, but the communication really works still. And also, there are a bunch of outright pros compared to Elm, the main of which is Purescript, which is the search engine for the code. So you get all the code libraries, all the Purescript libraries code is searchable by type and also by keyword. So you can find operators, type, function that conforms to some type, everything, and it tells you where they are, and it gives you documentation, and it's really nice. Also, it's got a clear direction because it's basically following Haskell, so you sort of know where they end up eventually. And you can work a lot with the REPL, which is maybe a surprise because usually strictly typed languages don't really work that much with the REPL. But since it doesn't have a runtime, you can build your program from scratch in the REPL and it will work. And it's got a very robust REPL, so you can do that. And if you want to do that, the Purescript by example book shows you how to do that, which is the official book. Also, it's got great tools. The tools are really nice. They got a lot of helper things, including type holes. So, maybe at some point you don't know what the type of something should be. So you just put a type hole, and the compiler will tell you what the type hole needs to be, what type it needs to be. And also, there is a search. So if the thing you're looking for is a function, it will give you all the functions that can fit that type hole in the libraries you've loaded. So it actually suggests you what you should put in there, which is really nice. And also, it's got the cool abstractions and less boilerplate. But the main con is it takes time to learn all this stuff. But the good thing is you don't have to do it, at the beginning. You can pace yourself. So I'll inflict on you my reflections about Elm, Purescript, and Haskell. So Elm is the simplest language. It's very focused on user experience. It comes before anything else. And as a consequence to that, it only gives you one way to do things. It makes all your choices for you. And they're also very merciless in removing any historical baggage, which keeps the language small and keeps the learning code small, the learning curve flat. And so I think it's a great entry language if you're curious about strongly typed functional programming, because you can, try it. In a week, you could have a working web application, single-page web app. But a limit is it only targets web browser. So if you don't want to make a single-page web app, then you're out of luck. So the next step on this ladder is Purescript, which is, I think, a very sensible language. They choose a middle ground between extreme power and extreme simplicity. They still have good user experience, especially with tools, but they also worry a bit more about power than Elm does. And also, Purescript is eagerly evaluated, so you don't have to learn about laziness. I mean, laziness is useful in many ways, but if you're learning, you don't want to worry about what laziness is doing to the performance of your code. So it's a bit easier to reason about. It's also got many backends, including Erlang. So you can generate Erlang from Purescript, also C++ and JavaScript. And then at the extreme end of power is Haskell, which is a research language. So all the coolest stuff, all the new things come to Haskell first. They may be a little bit unusable generally, but they are there, and they don't worry about user experience so much. And even though lately they've been worrying a bit more about tools, so there is Stack now, which is better than Cowboy. Cowboy was hell, as you might have heard. And they also have a bit of a difficulty with getting rid of historical baggage because Haskell is pretty old and it's hard to change things without breaking everyone's code. And also laziness adds complexity, as I say. It's very useful in some cases, but you pay for it all the time. In Haskell, you have to reason about it. And that is it. My reflection is done. If you are curious about higher abstraction, well, you don't really want to take the plunge and learn, I don't know, Purescript or Haskell, you can try them out in Elixir. There are 2 different libraries, and probably more of them that I don't know about. One is Algae, that's algebraic data types, and the other one is Witchcraft, which is algebraic and categorical abstractions. So you should check them out and see how they work for you. And also, if I made you want to try out Purescript, which would be very good, you should be aware that at the moment Purescript relies on Bower, which is a JavaScript tool, which has no clue whatsoever of what is going on with Purescript. So it will get you dependencies which may be unfit for your project if Purescript has had a new version. So after a new version of Purescript, there usually is a little bit of chaos that you have to work through. But it's easily solvable. You just get your Bower file and tell it to just give you a sensible dependency instead of a crazy one. This is annoying, but they're working on it. They're making a thing called PLC-package, which you can already use if you want, but it doesn't have all the libraries yet, I don't think. So I'll do a bit of a frameworks overview, dividing them by those who WAP React and those that doesn't, and also by type complexity. So this is a type complexity continuum. And on the easy end, we have Flare and Pux. Pux is basically the Elm architecture. And then there are lenses, and then there are dragons, which means free monads, on the other end with Halogen. So why would you start with Flare? Flare is a really nice little framework to make interactive graphs. It's really nice, and I definitely recommend it as a start. You might not want to use it because you don't care about interactive graphs. You don't want to do them. You also need to understand applicative functor syntax, which looks strange, but it actually makes sense. You just have to spend the time to figure it out. Also, why would you start with Pux? Pux is actually basically the Elm architecture. And for my particular use case, it already includes SVG, which was good. And also, you can use the interactive React debugger if you want to, which gives you a little bit of a time-traveling experience. I think it's probably the simplest Purescript framework which you can use to make a single-page web app. But why would you not use it? In my case, there was React dependencies. I mean, I really don't want to install all the 3,000 React dependencies. Fire, burn it with fire. But to show you that the Pux structure is basically the Elm architecture, here they are side by side. You see model is now state, and effects are the effects types that are in Purescript, but everything else is the same. In fact, it's so similar, I'm going to test you. I'm going to show you two pieces of code. One is Elm, and the other one is Purescript Pux, and you're going to tell me which one is Elm and which one is Purescript. Right? Which one was Elm? Yep. Well done. So moving on, we got lenses frameworks. I sadly don't know that much about lenses yet, but if you like lenses, there is Thermite, which is written by Phil Freeman, which is Purescript's author, so that should be good. It wraps React, and then there's Optic UI, which is a pure Purescript framework, pure Purescript. So last but not least, Halogen. Why would you use Halogen? If you use Halogen, you won't have to install the 3,000 React tools, which I think is a good thing. It's also used in production for a rather impressive app made by Slam Data, which is also open source, so you can look at their code. And they have at least 4 or 5 people working on it, which means it's quite polished now. It also has got basically the same DSL Elm does for making HTML, which is good for me. And 1.0 has arrived, so you probably won't have to rewrite your code every time a new version lands, which is good. And the bad thing about it maybe is that types get complicated and type errors can get quite crazy, so be warned. But still it works out generally. And the Halogen structure is still fairly similar to the Elm architecture. The model is state, the action is broken in action and request, there is a component type, and update is evil, which is a free monad, but you don't really have to worry about it. And view is render. Inputs need to be wired in the main function, which is pretty much almost the same as Elm, and effects use the Purescript effect and some extra stuff from Halogen. And I'll show you here the HTML DSL, which is almost the same as Elm, and it's really nice. And now I'm going to show you one application in Halogen, and that's just a button that toggles a Boolean from on and off. That's it. So you got the state, which is Boolean, and you got what would be the action, which is called query. So you got a toggle state, which changes the state of the Boolean, and then you got a question, like what state is the Boolean on? And then you have the component definition. So this is a component. It's pretty similar to how you would make a startup in Elm. You see, you've got an initial state, you got a render, you got an eval. So render is update, and eval, render is view, and eval is update. So they're still pretty similar, but you see the type over there. It's probably more than we used to in Elm. And then we got the render function, which you can see just as a button and an action being triggered by the onClick. And then this is the eval function, which has got another strange type, but you don't need to worry about it. It's got basically a pattern match on the action. So you can toggle the state, or you can check whether it is on. And that is it. That makes you a button that toggles on and off. So that's still pretty small code, and fairly similar to Elm, all in all. So if you want to get started with Purescript, there are a bunch of steps that I suggest. First one is to get it from NPM, or PSVM is good. It's a version manager for Purescript, so you can get a specific version. And then you might start reading the Purescript by example book, which is written by Phil Freeman, and it will walk you through learning Purescript. And if that goes a bit too fast, then you should probably get the Haskell book, because they're still so similar that the things you learn do come off. I mean, they are quite the same. So the Haskell book is actually goes step by step, so you can get it. And then you should probably take a look at the Purescript compat Elm library, because it shows you the same things in Elm and Purescript, and it shows, so you can see the things that are made differently. For example, like tuples are a bit different in Purescript. They're not first class, so you have to call a type. And then you could try out Pux or Flare. You should come out in Purescript channel on Freenode and say hi, and also come to the video meetup. And then maybe you should try out Halogen, make an app, and profit. So the conclusion is Purescript is a powerful and sensible language which has got a whole lot of abstractions, possibly more than you want, but all that you want. And it will take some time to learn. But you know, Elm is similar enough, so you have got an head start if you've done Elm before. And also, you don't have to know everything to start with. You don't have to know lenses. You don't have to know free monads. You can just start porting a small Elm app to Pux, and then everything will make sense in time. Also, it's not obsessed with user experience on the language side, but the user experience is still good. It's just not the main thing. So a nice comparison at the end. Elm works fine with Erlang. Purescript too. It even compiles to Erlang. And if it compiles, it works, and Purescript the same. And in Elm, boilerplate gets repetitive. You have to write the same thing quite a lot. And in Purescript, you don't really have that, but the types can get complicated. Also, you should never expect advanced type in Elm. They probably won't never put them. And you should expect a longish learning curve in Purescript. Also, Elm has got Haskell syntax, but without the squiggles. And in Purescript, you got Haskell syntax with all the squiggles in all the squiggly glory. A lot of squiggles everywhere. I got used to it. I thought this is madness, but then I got used to it. And there is really no roadmap in Elm. And while Purescript has got a roadmap, you can look it up on their GitHub. And I think Elm is a great entry language into strictly typed functional programming. And Purescript is a great second step in your road to Haskell, if you so want it to be. And maybe you should use Pux to start with that. So this is all, except that you can win one. If you're interested in embedded Erlang, embedded Elixir, whatever, you can win one of those 3 boards that I mentioned at the beginning. Internet of Things, Wi-Fi, bare metal boards. So you should look at this website and subscribe to the mailing list if you want that. And that's it.
Great talk. We're going to have 5 minutes for questions. See some hands. Awesome. For those of you in hard-to-reach locations, I would appreciate it if you could pass the microphone down the row.
Hi. One controversial question. You complained a bit about the Elm architecture, that Elm makes your decisions for you, but then you used like a Purescript library and you still mimicked the Elm architecture. And
well,
for the...
I'm kind of emphasizing that they are sort of similar, but they are not the same. But to show what they are not the same, would need to go in depth, and I don't really have the time to do that, and that would probably have to go through some types that are quite hairy, and I didn't really want to do that.
And the second question would be, what would be the pragmatic approach? Meaning, if you would have to build a project in, like, say, 2 months, what would be the path you will choose?
If it is, I think Elm is also good if you have a lot of programmers, say, that come in and out on the project. So if I had a bunch of programmers on the project that needs to get started now, and the application is a good fit for the Elm architecture, you don't have to fight against Elm, then I would use Elm. If instead it's not a good fit for the Elm architecture, then I would use Purescript. And maybe try, depending on the kind of programmers that are on the project and whether they can spend some time on it, then you would need to choose whether to go with Halogen or Pux, because Pux is simpler and Halogen is a bit more complicated. That okay?
Yeah, hi, great talk. What about the interop of Purescript with existing JS libraries, like the bullet client you use?
Right, so Purescript, in Purescript you can wrap any JavaScript library. It's a concept you can have. It's pretty easy. It's on their website. I haven't done it much, but there is a wrapper for D3, I think. There is a wrapper for a lot of different stuff. They even have a wrapper for React, so you have all of React wrapped in a low-level wrapper. So you can definitely do that.
Okay, so you will say it's better approach than Elm ports?
Well, it depends, because the point of ports is to make sure you're walling off your JavaScript is not making random runtime exceptions for you. So it makes sense, considering that choice, but if what you need is wrap a big JavaScript library, then that is a lot of work with ports, I think. So if I had to wrap a big JavaScript library, I would use Purescript.
Yeah, thanks. Yeah.
Thank you.
How do you compare the testing frameworks in these two languages?
Right. Well, Purescript has got quick check. I think Elm has got quick check as well. I really haven't used them much because types are your tests. I don't know. I haven't needed to use them because it generally works. But quick check is definitely a thing to check out in Purescript.
All right. Oh, 2 questions. That's fine. Here, please.
Hi, thank you for the talk. You said that you have been developing some parts in Purescript, and what was the experience like? Was there some pleasant surprises or annoyances, roadblocks?
Well, I mean, porting. The first experience is having to choose a framework because Elm gives you the framework and Purescript doesn't. For the rest, it's been quite pleasant overall. There is a learning curve to the types, to the abstractions, and that is fairly long. And I thought maybe that would be shorter. And I find it keeps going on, so maybe you get to the level when you know enough to go on with your program, and then there is still more, and there is more, and there is more, and they keep making more in Haskell, and then it comes back to Purescript, so it never ends. But you can still do a lot of stuff without knowing everything.
This will be the last question.
So you had the slide where you said that animations in Elm are complicated?
Well, more than complicated, you need to keep a lot of state around. There are some nice libraries in Elm to do animations. It just, since we were using SVG, it didn't really make that much sense for us to use them because CSS does the same things. And then you have less Elm code to keep up with.
Okay, but if you had to choose either Purescript or Elm for animation-heavy single-page web app, which one will you choose?
Well, I haven't really looked at animation in Purescript yet. It can certainly be done, but I only know about the Elm animation libraries, and they worked, they were fine. So it's probably the same problem anyway, because you do have to keep that state because it's pure, and you need to keep feeding the state around.
Give it up one more time for Claudia.